All right, welcome back, Contemporary Math. We are ending the near of the semester. The end is near. So here we go in chapter 5b. Should you believe a statistical study? So they give us 8 sort of guidelines, and we're going to go through these guidelines sort of one by one of the examples for each of them and talk a little bit more about it and what about these and what these mean. But we have the 8 guidelines. So the first one is to get a big picture view of the study. Number 2 is to consider the source. Number 3 is to look for bias in the sample. Number 4 is to look for problems in defining or measuring the variables of interest. 5 is to beware of confounding variables. 6 is considering the setting and wording in surveys. So they give a little bit of brief description of each of them here, but we're going to go a little bit deeper into each of these. So number 7 is to check that results are presented fairly. And then number 8 is to stand back and consider your conclusions. And so the first guideline we want to talk about, they say getting a big picture view of this study. So here they say you should understand the goal of the study, the population that was under study, and whether the study was observational or experimental. So that is their sort of guidelines for this one. So we want to look at this example, and I pulled a lot of these examples straight from the book, if I'm being honest, but I can give you a few more examples of some of these and hopefully get you on the right track. And I added a little bit about correlation and causation and spurious correlation in these notes. So that is typically in chapter 5E, but we won't be getting to that. So I wanted to make like a brief mention. And I know like everyone is probably going to raise their hand and ask, is this on the test? It's on the test of life. Like a lot of the stuff, I may or may not be able to test over it if I'm being honest, but it's going to pop up in your life. And I really think it's useful for you to have this information and to have this knowledge and to decipher and to sort the wheat from the chaff out there, right? So to speak. You have to understand like what is happening around you. I hope. Okay. So the first example, it says, imagine the following hypothetical news report. Researchers gave 100 participants their astrological horoscopes and asked whether the horoscopes appeared to be accurate. 85% of the participants answered yes, the horoscopes were accurate. The researchers concluded that horoscopes are valid most of the time. Analyze the study according to the guideline 1. So we want to know, is this observational or is this experimental? And so the way that they conducted this, they're giving them their horoscope. So in an experiment, we have a control group and we have a variable group. So we have one that would be getting the astrological horoscope. And if we were doing an experiment, there would be another one that did not get the horoscope or got a placebo horoscope, so to speak, right? And you would ask them whether it reflects what they're saying. And there have been studies like that, and there's no discernible difference between someone getting a placebo horoscope and a regular horoscope. I know horoscopes are a really popular belief, so probably might ruffle a few feathers if I say something too negative, but I don't believe they have any sort of determining factor, or they give us any sort of insight into what is happening, right? It no better than a common guess. And if you can't differentiate yourself from a common guess, then you're not really demonstrating that you have predictive powers, right? You're undermining that claim. Okay. And so the way that they conducted it is observational. And so what is a way that we could improve this sort of thing? Well, we would, if we wanted to do it a little bit better, we would do an experiment, right? So if you do an experiment, you're going to isolate the variable. So you want a control group. So that when they say, does this reflect what you believe, right? That people from the control group can answer yes or no. We can compare it to like a sort of placebo effect. Because if you give people these horoscopes most people are going to agree with whatever they say, or going to say that they are accurate. This is also something that gets at what we call confirmation bias, right? We notice the things that click, and we notice the things that line up within our life. We notice the things that resonate, and those things really stick out to us. And we have a tendency to sort of ignore the things that don't match up with what we want to believe. So that's also something that's coming into play here. So ideally we do this, and then ideally we would also probably do this in a double blind sort of study. The person giving the horoscope wouldn't know, and the person getting the horoscope wouldn't know, and the person giving them the horoscope wouldn't know whether it was the actual horoscope or whether it was something different that was made up. So with that said, I want to go a little bit beyond what they're doing here. So a little preface to this video. There is, if you're familiar with like the history of Houdini, this guy was kind of influenced by Houdini. So Houdini was obviously a magician who was known for like his escaping tricks and those sorts of things. But one of the things he did in his later life is he would go around to people that professed to have certain powers, people that were psychics or mediums, and they were basically charlatans, and he would out them as being charlatans. There are people that were basically taking advantage of people that were in vulnerable states. They are predators, basically, and Houdini outed them, so to speak. And James Randi kind of followed in his footsteps. His arch nemesis was this guy called Uri Geller, and if it sounds like it's gonna sound like I'm making these facts up probably, but Uri Geller got famous for bending spoons. He was definitely, I don't think he was the first. It's an old trick, but I believe it was the 80s. He got really famous for bending spoons. There was a Pokemon named after him, or kind of modeled after him, that he had like a whole lawsuit with, called Kadabra. It was a Pokemon. So I know it probably sounds like I'm making this stuff up, but you can go look at it. It's pretty common knowledge. He's still famous for some reason. I don't know. But James Randi was the guy that kind of outed him. And he also claimed he could turn pages with his mind. And James Randi put some foam peanuts around the book. It turned out he was just blowing the pages of the book. So he instantly lost his powers the second there were foam peanuts there. So, James Randi passed away recently, but here's a short video on that.
Shirla, did you pass that back? Wendy?
For the astrology test, each student was given a detailed horoscope.
Robin, did you pass it over?
They were told it was drawn up by a professional based on information they had supplied about when and where they were born. Actually, these horoscopes were not quite what they appeared to be.
I'd like you to share something with me, if you'd be so kind, just with a show of...
I asked the students to grade them for accuracy on a scale of 1 to 5, 5 being the most accurate.
How many gave it a 1? Let's see a show of hands. 2, 3, 4, and 5. Okay, so we scored pretty highly with this then. Let's do a little experiment. You've got your horoscopes right in front of you. Take them in your hand like this and hand them over your shoulder to the person behind you. Okay, everybody? And the guy at the end down there, you'll have to come up to the front, because these people in the front don't have one now. Okay? Everybody change them around. Everybody's got a... Open up somebody else's horoscope and read it carefully, please. What a surprise.
They had all received the same horoscope.
Okay, so what was the purpose of sharing that? What did he do? This is his sort of, well, I guess it's more of an observational study. He did something a little weird, and he did something a little different, right? So I might be a little bit of a fan of James Randi, but he's not, what he does isn't without critique, right? I can still critique what he's doing. And there is a lot to critique on what he's doing. Because what he did, if he wanted to set this up, like we said, ideally he would do a double blind sort of study. He wouldn't know what he's giving, and they wouldn't know what they're getting, right? That's not what he did here. He gave everyone a quote unquote horoscope. He gave them a placebo, is what he did. And he set this up to be more of a sort of observational study. So what he did is he made everyone within the control group. No one was a variable group. So if you wanted to improve this, he could make variable groups. He can make it double blind. So there are a lot of, I've heard of a lot of different experiments people have done, and they've done stuff with double blind studies. There is no sort of proof that they can give us any sort of insight into, or any sort of predictive powers into what's going to happen. So example 2 says consider the source. So this has some interesting implications. So by 1963, enough research on the health dangers of smoking had accumulated that the Surgeon General of the U.S. publicly announced that smoking is bad for health. Research done since that time has built further support for this claim. However, while the vast majority of studies show that smoking is unhealthy, a few past studies found no dangers from smoking and perhaps even health benefits. These studies generally were carried out by Tobacco Research Institute, funded by the tobacco companies. Analyzed the Tobacco Research Institute studied according to Guideline 2. So the book has a funny little tidbit about how Philip Morris was like pretty much behind this for the longest sort of years. I don't remember exactly what year they finally admitted smoking actually is bad for you. And then the second they admitted it, they changed their name, their business name. So the book notes that. It's kind of funny, but it's also kind of horrible. They're not taking responsibility for what they've done, basically. What does this get at? And I think there's a more important sort of life lesson here, right? When we want to find out the credibility of stuff, we have to get multiple sources. We have to get multiple credible sources. Any other thing? This is also the sort of thing, if we sort of cherry pick our information, right? You might find that one test that tells you the odd thing that you want to find out. And maybe there's like 5 tests dismissing your claim. So you really have to know more about like the statistics behind it and what they're doing, and to see what they're doing. And one of the best ways to see whether the conclusions they're drawing is supported by the evidence they have is to get their raw data and do the statistics yourself, to do the calculations yourself, and to understand where these calculations are coming from. With that said, there are some flaws, but in general, we have this thing called the peer review process within higher academia, right? We have peer journals that get submitted, and when those peer journals get submitted, they get reviewed by other people that are professionals in the field. People look at these things generally. Occasionally, you will see people like publish stuff that's nonsense. But with that said, they usually get outed pretty quick within academia and within these scholastic sources. If someone's publishing something that's not true, usually they get checked and it gets rejected pretty quick. And the people that published it get a little tarnish on their reputation. So, but there are unethical people out there. So with that said, sometimes things do happen like this, right? Certain biases come into play and people fund certain studies. And I remember when I was studying statistics, I had a professor that said, well, if a company comes up to you and asks you to produce certain results, that is completely unethical. And I think I said that in the last section, right? That's not the way statistics work. The numbers tell you what the numbers tell you. The numbers don't lie, people misinterpret them. There's a little popular saying we used to say. But the way to keep from misinterpreting them is to have a better understanding of these statistics. These studies generally were carried out by Tobacco Research Institute. So with that said, obviously the Tobacco Research Institute is not going to want to admit that their product is harming people. So if the only study saying that tobacco smoking is good for you is coming from the people monetarily benefiting from it, getting money from it, then probably be a little bit skeptical of those studies, right? The other thing, there's a few examples of this happening throughout history too. Like it's not completely unheard of. Thinking about a few examples, there was for the longest time, I want to say it was ExxonMobil, but I might be wrong. They try to deny, a lot of gas companies try to deny that lead in the air was dangerous, or that lead was even dangerous. And there was a lot of studies done on that, where there was one guy that really did a study and figured out it was dangerous, and he had a really hard time bringing this to people's attention. They didn't want to admit it. And a lot of the studies dismissing it were sort of led by the gas companies, because lead was a really common additive in gas. And so there was lead in all the gas, and it would burn, and you would burn it in your engine, and it would go into the air. And lead is dangerous and really toxic in like almost any concentration. So this is like a really bad thing that was literally poisoning everything and everyone. And so now that's why you see when you go to your gas pump, they have that word on there. It says unleaded. It means there's no lead in your gas. I know like a few people that have antique tractors. Sometimes you have to put lead additive. There's a fake synthetic lead additive that like you have to put in certain old engines to keep them running. So that is a thing that does happen. But the other thing that I can think of off the top of my head is sort of like, the global warming studies that take place. From my understanding, a lot of things that try to dismiss global warming are like funded by, Koch Brothers Inc., the people that are profiting off of basically destroying the world. So what else? Guideline 3, look for bias in the sample. Bias in choosing a sample. So there are two sorts of biases they want to talk about: selection bias and participation bias. So when we're doing an experiment, this is when we're selecting our sample. Biases that can occur in selecting our sample occurs whenever researchers select their sample in a way that would tend to make it representative of population, or unrepresentative of population, sorry. For example, a pre-election poll that surveys only registered Republicans has selection bias because it's unlikely to reflect the opinions of all voters. Pretty straightforward, I think, there with their wording. So when you're selecting it, you want a sample that is representative of the larger population. The other thing is participation bias. So the participation bias occurs when people select or choose to participate in what you're doing. So depending how you're performing your study, it could influence who's choosing to be in that study, right? If participants must take action to participate in a survey rather than being selected at random, those who feel more strongly about the survey issue are more likely to participate. So this is the town hall effect, right? You're going to get the people screaming at you a lot more than the people that are apathetic towards what's happening around them, right? Surveys or polls in which people choose whether to participate are often called self-selected or voluntary response surveys. So you're going to get a lot of people that are like, not so many busy people here, right? A lot of people that are really bored and ain't got nothing better to do sometimes. Or they're really passionate about the issue. So you get biases within who wants to participate within your study. Okay, so they give you, I guess, another example. And here is where they start talking about the Gallup polls, what they talk about right after this, because they talk about this guy, the Literary Digest, a popular magazine of the 30s, successfully predicted the outcomes of several elections using large polls. In 1936, the editors conducted a particularly large poll in advance of the presidential election. They randomly chose a sample of 10 million people from various lists, including telephone books and rosters of country clubs. They mailed a postcard ballot to each of the 10 million people. About 2.4 million people returned the postcard ballots. Based on the returned ballots, the editors of the Literary Digest predicted Alf Landon, and if you don't know who Alf Landon is, it's because he didn't win, would win the presidency by a margin of 57% to 43% over the incumbent Franklin D. Roosevelt, which we probably all know his name. So instead, Roosevelt won with 62% of the popular vote. How did such a large survey go wrong? Okay, so this is basically they're getting at selection bias and participation bias. So we want to talk about those two things, how they're in this example. And we also want to talk about maybe like how we can get around it, right? We don't want biases in our sample. We want them to be representative. We want to be able to sample something that's representative and talk about our population. So how do we do that? How is it in here? The first one is selection bias. So they talk about these two things. Scout telephone books in country clubs. So if you're sampling people from country clubs, I have never been a member of a country club. So these people are going to have a lot of money. Telephone books. So I know maybe we're not in the 30s, but telephones were relatively new in the 30s, I believe. Okay, so the first one was invented in 1876, but they were really kind of expensive here, and it mentions that in the book. And so in the 30s, telephones were still relatively sort of expensive. So you're getting the telephone books and you're getting the country clubs. You're really only getting the people with lots of money, right? Was it 5 monies means a lot of money, right? On a scale of 1 to 5. In the Zagat's, I think, no, I don't know if they use that scale. So this is selection bias, right? We have the selection bias of money. Selection bias. The other thing is this keyword. We did mail ballots. We did postcards. We're mailing postcards. We're only getting people that want to return the thing. Only the people that feel passionate about this election are probably going to end up answering this and sending it back and wanting their opinion known, right? So people that are more apathetic of the election probably aren't going to care. Like if I get something in the mail that's politically related, it's probably going right in the recycling bin, right? So I'm not going to answer a survey. I'm too busy for this stuff. So they're not going to get people like me. So they have selection bias and they have participation, right? And the keyword in the participation bias is that we're getting postcards and return ballots. So how would you do this? You would have to select a better population. When you're doing your experiment, you're going to have to select it. Probably not through a phone book. Probably through a census or something like that, right? Where you would actually get everyone that's possible that's the vote out there, or through a voter registration. So I believe you can also look up registered voters. And you can do that. It is public knowledge whether you voted or not. They can't see who you voted for, but they do know whether you voted. That is public knowledge. Not a lot of people don't realize that. But how would you get around participation bias? There's not a lot of really ways that we can do it here, to be honest, right? You could force people to take a survey. So I don't know how you're going to force people to take a survey. It's kind of a hard thing to do on this. Maybe more direct response. So this is if you notice, they're going to mail them a postcard, right? If you go knock door to door, you might get a better response or people might tell you to bug off. So who knows? But if you do it in person, sometimes you might get a better sort of response. Doesn't necessarily mean you're not still going to get the participation bias, but maybe it will minimize it a little bit more, right? It puts more of an obligation if someone actually sees a person in front of them. So there are certain things, and like I said, there's not any one sort of direct answer. There's sort of things we need to acknowledge here, right? And things that we need to talk about. And there's things that you might suggest that I might not think about, right? That is a possibility. Okay. Let's skip over something. Oh no, this is another example. You want to know whether Americans generally support or oppose a new healthcare plan. Which of the following approaches is most likely to give you an accurate result? And so this, again, we're looking at this with respect to number 3, which is looking for a bias in a sample. So we want to talk about our sampling methods. We want to talk about the 2 biases, selection bias and participation bias in these. So they give us 5 different little examples here. So short interviews with 1,000 randomly selected Americans conducted by professional polling organizations such as Gallup or Pew Research. And death interviews with 10,000 Americans selected at random from among those who have been hospitalized in the past year, conducted by a professional polling organization. Short interviews with 100,000 Americans, chosen by asking 100 randomly selected people at each of 1,000 grocery stores at 9 a.m. on a particular Monday morning, conducted by volunteers working for a citizens group. A poll in which more than 2 million people register their opinions online, conducted by a television news channel. A special election held nationwide in which all registered voters have an opportunity to answer a question about their opinion on the healthcare plan. So in this, which of the following is most likely to get you accurate results? So I'm just going to jump to it. I'm just going to say they say in the book, and they give you us A. And if we think about participation bias and we think about selection bias, this one will be the best, right? We're randomly selecting Americans. If you go look at how the Gallup and Pew Research poll does that, they do a good job at doing it. Typically, they are, the sort of professionals in the field, so to speak. And so we won't see a lot of selection bias because they are randomly selected. From my understanding, I believe Gallup does it through telephone. So you do get some selection bias, but most people have a telephone at this point, right? So it's become a more accurate sort of way to measure things. And so this one is the one that they're going to say is going to minimize both selection bias and participation bias. So if we want to look at these other ones, one of those 2 things is probably going to pop up more so in these examples if we think about it. So one thing I do notice is we talk about maybe the sample size. So if you're looking at the sample size and you're like thinking, hey, this is going to be more accurate because we got a larger sample size, this would be more accurate. This would be more accurate. That would be more accurate. That is probably a correct way to sort of think in general. But just grabbing more and more people from a certain sector of the population is actually just going to amplify the bias if we think about how we're drawing that population. So you're just getting more people from a certain sector of the population, even though you're getting a bigger sample, right? So it's still going to be really, really skewed. So it's better to get a smaller sample and to get them randomly, is the sort of argument that's happening here, right? These people are selected at random, so we do get randomization. A little bit, but the keyword is you want something about healthcare. We want an opinion about a new healthcare plan. Okay, so the keywords being here is that they've been hospitalized in the past year. So when you talk about people that have been hospitalized in the past year, and we want to talk about the biases there, that is where you're getting participation bias or selection bias, right? You are selecting people that are, that'd be a selection bias because you're selecting the people that are from the hospital. So I don't know what professional polling organization this is, but they're not doing a too good job. That's selection bias right there. How's it going to bias it? Well, if they've been hospitalized and they need healthcare, they're going to probably be pretty pro healthcare. So short interviews with 100,000 Americans chosen by asking 100 randomly selected. So we're randomly selecting people, but you're randomly selecting people. And the keyword here is you're getting people at a grocery store at 9 a.m. on a Monday. So there's a bit of a selection bias there because we're only selecting people that are probably not workers, right? You're probably going to get a not workers selection bias. These people are at a grocery store at 9 a.m. on a Monday. They're probably not going to a 9 to 5 Monday through Friday, or they might have a different sort of job, right? So they are probably not, you're probably not getting people that are employed in the typical 9 to 5 is what I'm trying to say. Not that they're not working. They're just not employed in the typical 9 to 5, right? You're getting people, you're getting a selection bias in that way. The other thing is you're bothering people at 9 a.m. when they probably just woke up. So that's probably a really good way to get a participation bias in there. Not a lot of people are morning people, so they may not want to do your survey at 9 a.m. when they're trying to get their grocery shopping done. So there is selection bias. There is definitely some participation here. And then if you think about this one, there's also participation in the hospital one, right? People that are really opinionated that didn't get the healthcare they needed are going to be really opinionated about what the healthcare needs to be. Okay. And this doesn't say how they selected the grocery stores, but you'd also want to select your grocery stores at random as well, right? Different neighborhoods have different level grocery stores sort of thing happening. So you could be getting a sort of income bias there if we don't select grocery stores in various neighborhoods. A poll in which more than 2 million people register their opinions online, conducted by a TV news channel. So this thing is pretty much the setup for participation bias. You're only going to get people that want their opinions known to give you your opinions, right? The other thing is there is a bit of a selection bias, maybe not so much anymore, but this may be like the selection bias as you're doing things online, right? So if you're doing things online, you're only going to have people that have a connection to internet access, right? So if, and this might be important to you because like not everyone has online access. So if you want to talk about like the homeless population in Austin, a lot of those people don't have online access, right? And so you're not going to be able to get their opinions on things if you do things online. So that's one thing that kind of sort of comes to mind. A special election held nationwide in which all registered voters have an opportunity to answer a question about their opinion on the healthcare plan. Okay, so this sounds like sounds like the town hall sort of thing. You're going to get the participation of people that really want to. With this election, I think they probably maybe did a pretty good selection of selecting all registered voters, right? That would help minimize probably their selection bias. But they also don't talk about when the special election was held. There's a lot of sort of key factors here that might also have some selection bias in it that we don't get the knowledge of, right? Maybe. The other thing, yeah, that's it. Selection and participation bias. Okay, we talked about both of them. Okay, so guideline 4 says look for problems in defining or measuring the variables of interest. So these are things like what we're going to talk about, and they say ambiguity in the variables can make it difficult to interpret reported results. Okay, so they define what a variable and they define variable of interest. So a variable is any item or quantity that can vary or take on different values. The variables of interest in a statistical study are the items or quantities that the study seeks to measure. So a Roper survey of randomly selected individuals who are among the wealthiest 1% of Americans found that these people would pay an average of $487,000 for true love, $407,000 for great intellect. So this is a really horrible example, but here we go. $285,000 for talent and $259,000 for eternal youth. Analyze this result according to guideline 4. Okay, so we want to talk about the variables and the variables of interest. So the variables that they're talking about here are something like what? True love, great intellect, talent, eternal youth. So we want to talk about ambiguity, right? Is the key word here. How are these things ambiguous? We want to talk about true love. So true love, what is true love? How do you define true love? Go ahead and do it. Try it. I don't know. So this is a very sort of ambiguous. Here we go. It's a sort of ambiguous sort of term, all these things, right? When we talk about true love, these are not things that are well sort of defined. What does great intellect mean? Some people are really, really proficient in certain areas and not so much in others, right? What does it mean to be talented? What does it mean for eternal youth? How are we going to define these things? These things are not well defined here. They're a bit ambiguous. What does it mean, right? So they were seeking to, what they're seeking to measure is the value of these things and how these people valued them, right? But the problem with that is that one person, like I said, one person's definition of true love may not be another's. One person's definition of great intellect may not be another's, right? So we could be talking about very, very different things when we talk about talent. I could be talking about talking about balancing a cue stick on my hand or something, right? And you could be talking about learning how to play the guitar. Those are very different things. One person might consider one talented and consider another not talented. Who knows, right? Okay. So the problem here is that these variables of interest are very ambiguous. They're not well defined. It doesn't really give us a lot of predictive properties into what this really means. Okay, so a commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10% of the illegal drugs entering the U.S. Should you believe the statistic? And the book pretty flatly says, like, this seems like something made out of thin air. And part of the reason why they say that is we're talking about illegal drugs. So if you want to know that 10% were stopped, you would have to know the total amount going through. So what is the total amount of illegal drugs going through? How do we figure this out? Do you go around asking people, hey, are you trafficking illegal drugs? There are ways that maybe we can get at this a little bit, like with overdose rates and things of that nature, but these things are kind of, it's a bit hard to pinpoint, right? And this seems like a really round number. It seems pretty made up. And that's kind of what the book says. Like, how do you know the total amount of drugs going through? That's the variable of interest. And so this is a bit ambiguous, right? We don't know the total illegal drugs going through. So how do we know that they're really stopping 10%? Could be more, it could be less, right? They could be pulling a Smokey and the Bandit. Who knows? Okay. Where are we at? Guideline 5, beware of confounding variables. So I think I might have mentioned this briefly before in class or one of the lessons. Confound confound means to confuse, right? So what this means is that there's a variable that's confusing the study. This means like there's a third variable that we're not thinking about. There's something out there that we're not thinking about that's playing in or could be playing in. There could be a third, there could be a fourth, right? There's something out there that we're not looking at. Okay, so radon is a radioactive gas produced by natural processes, the decay of uranium in the ground. The gas can leach into buildings through the foundation and can accumulate in relatively high concentrations if doors and windows are closed. Imagine a study that seeks to determine whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, where radon gas is fairly common, and with the lung cancer rate in Hong Kong, where radon gas is less common. Suppose that the studies finds that lung cancer rates in the two sites are nearly the same. Is it fair to conclude that radon is not a significant cause of lung cancer? Short story, no, it's not fair to conclude, right? And let's talk about why. So the no should be the easy part, right? I'm hoping. explaining, we want to explain this a little bit. So if we think about, we're going Colorado versus Hong Kong. If you've ever driven through Colorado, it is still a lot of rural areas in Colorado. In Hong Kong, that is a metropolis, that is a city you're talking about. So when you think about cancer and things that cause cancer, obviously air pollution is going to be one of them. So they're talking about just radon here, but there's other air pollutants out there, from carbon pollution from plants nearby in Hong Kong. So we have air pollution from plants that are going to increase the rate of lung cancer in Hong Kong. The air is a factor, right? So with that said, there's a third sort of variable here, and that's called being in a city versus being rural, right? So it's not fair to conclude, and it's not fair to conclude because there could be a confounding factor. And so with this said, I want to talk a little bit about correlation and like causation. And the book gives these definitions, and I'll bring it back around to confounding variable. So it might seem like I'm going off a little bit, but it'll come back around to what we're talking about, I think. So correlation exists between two variables when a higher value of one variable are consistently associated with higher values of another variable, or when higher values of one variable are consistently associated with lower values of another variable. So this is talking about direct correlation and inverse correlation is what it's talking about. And so if you have direct correlation, that means one of the things goes up, the other thing goes up. It goes down, it also goes down. So they travel with each other, so to speak. And the other one would be like inverse correlation. If one goes up, the other one goes down. And if one goes down, the other one goes up. With this said, correlation is the first step to proving a sort of causal relation. There is a difference between a cause and a correlation. So basically, we're looking at a graph and we plot, which we won't talk about till next time. The correlation means we can get a line and it's going to look fairly consistent with the data that we're getting. It's either going to go up or down. These two things are going to correlate with each other strongly, is what we'll say. If we get something that's really scattered, plot, there's not really a way to draw a line, and so we wouldn't say those things are correlated. But correlation just means the relation between the two things. It doesn't mean one of them is causing the other. That is a different sort of implication being held. If we want to talk about causal links, one thing causing another, like if I flick the light switch, then the light comes on, right? There will be a strong correlation between flicking light switches and the light coming on. All right, but there are also things out there that correlate that are not causal, and we'll talk about those in just a second. They are called spurious correlations. But if we want to prove that something causes something, so if I want to prove the light switch controls the light, and this is going back, oh man, to that logic in that first chapter, the if-then statements were causal statements. If-then, if I flick the switch, the light comes on. So if we want to prove that the switch is causing the light to come on, the first step is doing the correlation, to flick it and see when I turn it on. When I flip it up, the light is on. When I flip it down, it's off. That produces a very strong correlation between it being on and off, up and down. The cause and getting at a cause. So first we prove a correlation, but in order to prove a cause, we actually have to prove there's a mechanism there. And so with the light switch, I can actually make an argument about the mechanism that's happening with the light switch. I know things about electricity that I can plug into there, and I know things about, pun fully intended, I know things about electricity that I can plug into this argument. I know things about the way that the switch works that I can plug into the argument. And so I know all these mechanisms of how electricity works and how switches work. And I can make an argument that the correlation here is a causal link because of mechanisms, right? But we have to actually talk about the mechanism in order to get a causal link, because correlations themselves do not give you causes. And there's a sort of really famous example. They don't give you causes, and they don't necessarily give you the direction of the cause. So if we talk about like what firemen versus fires, If we count the number of fires and the number of firemen, those things are going to be really, really positively correlated. The more firemen I have, the more fires I have. So there's an old joke. Does this mean that the firemen are causing the fires? If I get more firemen, I get more fires. So the conclusion there is, well, firemen are causing fire. No, they don't cause fires. They're putting out the fires, right? And so what we're actually doing, and it might be more beneficial, is typically we do the cause here, right? The fire and the firemen, right? So it might be better to do this graph in this sort of fashion because there is a causal link. The fires are causing the firemen to be there, right? So that would be the causal link. But there is a correlation between the two, and it doesn't tell you which one causes the other, right? These are strongly correlated, but it doesn't give you the direction of the cause. We have to bring in knowledge from our outside world, knowing that firemen are there to put out the fire, to say that the fire is causing the presence of the firemen, right? So we can make a causal inference there, but we're making that inference because of the mechanisms we know about fires and the mechanisms that we know about firemen. There's also one with sick people, right? And doctors, and the king recognized that, well, everywhere that there's a bunch of sick people, a bunch of doctors, there's a bunch of sick people. So he concluded the doctors were causing the sickness and executed all the doctors. But hopefully we got some more rational people in charge. So there are different levels in which you can say a cause exists, is what they're getting at here, right? If we prove a correlation, that is the first step to seeing if something causes something. But it doesn't prove that it causes something. It's the first step we're taking. We still have to think about mechanisms. So impossible cause, they said, well, we discover correlation. Well, it's possible they might be, but it's not, there's like no guarantee. And they make a mention, possible cause is often, a reason to start an investigation. But next we want probable cause. A probable cause means we have good reason to suspect that a correlation involves a cause. Maybe we have some guidelines for establishing causality. Probable cause is the general standard for getting a judge to grant a warrant. So you actually have something somewhat substantial and getting a mechanism, right? And then we actually have found the mechanism, we've found the physical model, we've modeled it to such an extent that it seems to be unreasonable to doubt that this is the way that's happening. Okay. And so this would be I know the light switch works to the light, right? I know the mechanism that's behind there. It seems absurd to think that if anything else is happening with the light switch besides I'm flicking it and it's turning it on, sort of, so to speak. And they give a little bit about what that means, right? Cause. Okay. So with that said, there are things that correlate that we don't know whether there is a causal relationship or maybe there is no causal relationship. Maybe it's caused by a confounding factor. So in statistics, and this is straight out of Wikipedia, I just copied and pasted it, spurious correlation or spurious relationship is a mathematical relationship in which two or more events or variables are associated but not causally related. So due to either coincidence, it could be completely coincidence. And I think this is getting at the fact that correlation is not causation. And this is what I really want you to take from this sort of section. We want to find things that cause things. We want to understand things about causal relations in the world around us. It gives us power to predict things. It gives us power to prevent things from happening that are bad, right? It gives us the power to do things that are good, right? It gives us power to act. It gives us knowledge of the world around us and how it works. With that said, we have a sort of bias to want to fill in these sort of gaps, I feel like. When we see correlations, we really want to think that they are causal, and they may or may not be. So we have to really look, and we have to propose mechanisms, and we have to do quite a lot of research to propose causal links. Correlation by itself is not doing it. With that said, there is some pretty, there's some humor, a little bit of humor behind these, but these are a lot of like mortality statistics too. So it might be a little bit of dark humor. I don't know what to tell you. But U.S. is spending on space, science, and technology, and suicides by hanging, strangulation, and suffocation. So these two things absolutely correlate. What do they have to do with each other? If you can guess it, I have no idea. But they have a really strong correlation, which basically means when this one goes up, this one goes up. This one is the number of people who drowned by falling into a pool in films that Nicolas Cage appeared in. If you think those two things have anything in common, I don't know what to tell you. I don't think they have much in common. But there's a fun little thing I think our brains do, right? It's like, is Nicolas Cage causing these people to fall into the pool? We want to assign like causal relationships here, right? We want to like, oh, does that mean that? No, it doesn't at all. This is completely spurious. Things can correlate and go up and down by coincidence. So this seems like it's probably sheer coincidence that these things are happening. Maybe. Hopefully. Hopefully he's not killing people. Probably not. So coincidences in reality, they absolutely happen. Sometimes things line up, right? That's what this is basically saying. As one goes up, the other one goes up. As it goes down, it goes down. They are matching up by coincidence. It does not mean one thing causes another. So I think that's an important sort of thing to take away from statistics and understanding the world around you. Okay. So next thing is number 6. Consider the setting and wording in surveys. Ooh, I like this one. This one actually gets at something that you might even talk about in your psychology class. So if we want to look at this, it says the Republican National Committee, or the RNC, commissioned a poll to find out whether Americans supported its proposed tax cuts. They asked, do you favor a tax cut? A large majority answered yes. Should we conclude that Americans supported the proposal? So the key word here is the wording, right? Do you favor a tax cut? If we look at this way this is worded, this is already sort of favoring people to say yes to this question if we think about its wording. If you wanted a more non-biased, maybe you would say, what is your opinion on a tax cut? Or what is your opinion on taxes? All these words seem to really like kind of lead you. Do you favor? People in general want to favor and they want to agree with things, right? In general, it's just easier to go along with the flow, and for the most part, right? So in general, people want to favor and be agreeable. So do you favor this? People are going to be inclined to answer yes, versus more if you ask, what is your opinion on a tax cut? And maybe what is your opinion? Versus do you favor or are you opposed to a tax cut? So if I ask you, are you opposed to a tax cut? That's going to lead people into saying they're opposed to a tax cut. So with this, there's certainly like something to be said about the way that we word our questions and investigation or experiments, investigations that take place, right? And so there is a short sort of little video I want to show.
We're on location of a movie set in the 1950s, complete with cameras, bossy director, and on-set police for security. We've also invited a group of spectators to watch the filming. Pay attention along with them as the crew gets the final shot of the movie. Try to remember what you see.
There we go. Final shot, everyone. Action.
Keep watching. Everything you see is fair game.
Watch out for the car! Cut!
Okay, that wasn't part of the movie. Did you catch what just happened? I know, it was a lot to take in. But we're going to let you in on a little secret. The actors, director, crew, and police are all in on it. Everyone, in fact, except our spectators. And former Las Vegas Police Sergeant Chris Curtis is here to test your memory. He's going to ask you and our other witnesses 3 questions about what you just saw. Ready?
What color was the car that got hit?
think back and try to be accurate. Got your answer?
Did you say blue? Good, that's correct. Next question. How fast do you think the car was going when it bumped into the other car?
What do you think? Was the red car going 10, 15, 20, 30, or 40 miles an hour? Got your answer? Did you guess around 20 miles an hour? If so, you agree with 80% of people we showed this video to. Before we reveal if you're correct or not, let's see what our spectators have to say.
How fast would you say the car was going when it smashed into the other car?
I'd say 40.
Between 40 and 50.
It was going about 30 miles an hour.
Definitely 50 miles an hour.
These people think the speed was really high. Is that what you thought? Or did you think it was much lower? It turns out the actual speed was 20 miles an hour. Is that what you guessed? So why were our eyewitnesses so much higher? The thing is, only some of our witnesses guessed high. Others were much closer to the real speed.
How fast do you think the car was going when it bumped into the other car?
Probably about 10, 15 miles per hour.
15 miles per hour.
15 miles an hour?
Yeah.
Okay, how can this guy think it's 50
Between 40 and 50.
and this guy think it's 15?
15 miles per hour.
After all, they both saw the same crash. But if you've been paying attention, you'd know it's not the crash that matters, it's the question. Listen carefully to Sergeant Curtis.
How fast would you say the car was going when it smashed into the other car? How fast do you think the car was going when it bumped the other car?
Did you catch it? He said smashed. To some witnesses,
Smashed into the other car, smashed into the other car, smashed, smashed, smashed into the other car.
and bumped to others, including you.
When it bumped the other car.
The word smashed actually increased the speed of the red car in our spectators' memory.
So I want to tell you, the actual speed of the accident was 20 miles an hour.
I don't believe that. That's crazy.
Yeah, that would surprise me.
It seemed like it was 30 miles an hour.
You're kidding, right?
That's a big difference.
It's incredible if you think about it. One word has the power to totally rewrite a memory. Don't feel bad if you got the speed of the car wrong. We're going to give you another chance to test your memory.
Final question. You saw the driver blow through a stop sign right after the accident. Yes or no?
Before we reveal the answer, let's see what our spectators have to say.
Did you see the car run through the stop sign after the accident?
Yes, I did.
Yeah, I saw him go through the stop sign.
Absolutely. Absolutely.
Watch the replay. Do you agree the driver ran through a stop sign? Look closely, and you can see it's actually a yield sign. Did Sergeant Curtis mess with your memory again? If so, you're not alone.
Would it surprise you to know that it was not a stop sign, but it was a yield sign?
Let's go back and check it out. I think it was a stop sign.
So what was going on in your brain when Sergeant Curtis manipulated your memory along with our participants? Experts call it the misinformation effect, and it reveals memories are never a perfect recall of an event.
Every time you receive new information from a trustworthy source, your brain reshapes your memory based on those details.
And memories formed under stress, like a car accident, are especially vulnerable to change.
Okay. So I know it might be a little bit tangential because they're talking about like memories and how memories are formed, but they are doing something really important with like the wording of the questions there that I wanted to like focus on. So just by the way he words those questions, he is forming or influencing the way those people form their memories, and he's influencing the way that they remember an event, right? So with that said, there are ways that you can implant memories in people that are sort of like what he was doing, right? You can really manipulate and influence people. And some people, with that said, you know, you can manipulate people for their benefit, or you can manipulate people against their benefit. I've heard of instances where people all claim to see aliens or something along those lines, and it turns out they're all seeing the same psychologist. So pretty strong correlation there. Probably a pretty strong causal link there too, if I were to imagine. So with that said, just knowing these things and knowing how your wording in itself can influence the way that people perceive reality, right? That was the key lesson I really wanted you to take away from that. Is that the wording itself is actually influencing the way that they're seeing reality. So you have to be careful with that, whether you're conducting a poll or whether you're a police officer or a law enforcement officer out there. You have to be aware that your biases can influence other people, right? And the way that you go about asking your questions can actually influence the way that people answer them. So this is a really important sort of factor to know if you're going to become an investigator, right? The questions you use, whether they're leading or not, are really important. The way that you word it. And the other thing that also will influence your questions, right, is the order that you have your questions in. So that's also another thing that people also sometimes have to check. Because we have this thing to remember the first and last thing that we read, typically primacy and latency, right? So we have that natural bias that also sometimes you got to check. So example 7 is checking the results are presented fairly. So this is kind of being able to interpret things for yourself. There are a few assumptions they make here. They do assume that things maybe are probably normally distributed, and we don't go into that section, but there is a difference between your mean and your median. That we typically think about the arithmetic average. The arithmetic average would be your mean. The median is also known as percentile. This is like if I take all the numbers up and divide it by the total numbers that are there. Right? If you're finding out your grade average, that would be like the mean or the average of your grade. The median is also another way to measure. They call these measures a central tendency. And colloquially, we call everything kind of like the average. If we want to talk about the average person or the average height, we would take the mean of the heights. And a lot of stuff is sort of normally distributed. So they are, if it's normally distributed, we can assume these things are the same. We can assume that if we average the heights, half the people will be below that and half the people will be above that. And we can assume that because it's not skewed. So we don't really go into like the populations and stuff like that, but they are sort of making this assumption here, and they don't really say it, but they kind of are making this assumption that these are the same thing. In order for these to be the same thing, they would have to be normally distributed. So if that's true, the announcement was based on reading tests doing this thing, and they figure out that 28% of the children were reading below grade level. So if 28% are below grade level, that might seem like a large number, but if we think about what's above, that's what, 72%. So 72% are reading above their grade level. So that sounds a lot better if you say it with this one first, right? And so if we talk about the 72% being above, this actually means that they're scoring slightly above what the average probably class would be doing. So this doesn't really support their conclusion that their teaching practices are bad. They might need to revamp their teaching practices, but this definitely does not demonstrate it, right? Okay. Stand back and consider the conclusion. So this is the final example, the last guideline they want to talk about. And so in the little brief snippet, they say, evaluate whether the study achieved its goals. If so, do the conclusions make sense and have practical significance? Okay, now they're breaking it down. Did the study achieve its goals? Do the conclusions make sense? Can you roll out alternative explanations? So this is something we want to be able to do. We want to be able to look at everything that could possibly happen that could be confounding this. We want to look at other variables. And we want to sort of be able to rule them out that, hey, this isn't the thing that's actually controlling it, right? We want to make sure there's not a third variable there that we didn't think about. If the conclusions do make sense, do they have any practical significance? So here's the example that they give in the book. So an experiment is conducted in which the weight losses of people who try a new fast diet supplement are compared to the weight losses of a control group of people who try to lose weight in other ways. After 8 weeks, the results show that the treatment group lost an average of 1/2 pound more than the control group. Assuming that it has no dangerous side effects, does the study suggest that the fast diet supplement is a good treatment for people wanting to lose weight? Okay. So what about the study? Did it achieve its goals? What was its goals? Was it to find that the fast diet supplement is a good treatment for people wanting to lose weight? Does their conclusion make sense based off of what they did? So they're finding 1/2 pound, right? So it seems like they did this in probably an appropriate way. It seems like a good sort of way to do this, right? We're doing 1/2 pound difference that they find between the people that took the pill and the people that did not. All right, so I don't think there's really probably anything wrong with their methodology here. But if we're talking about 1/2 pound and we're talking about like a what, 150, 200 pound person, that's not very much in the grand scheme of things, right? That's not a lot to really determine that it's really working more than the other. And the other thing here I don't really like, they don't give us a population size, right? Or the sample size, I mean. They don't give us a sample size. They don't tell us how many people we're sampling. That also kind of makes a difference in how significant this result might be. But in the grand scheme of things, does it have practical significance? If I told you taking this pill over and over again is going to make you lose, what, 1/2 pound more? Is that 1/2 pound really a whole lot when you consider your weight, your whole weight to be like 150 or 200 pound person? Probably not even, it's not even anything that you would really consider too much, right? It's like 1/2 pound. So it looks like, and I think the book says this, it looks like they conducted this experiment in a decent sort of fashion, but the main problem here is that it doesn't have any practical significance, right? 1/2 pound isn't going to matter to you in the long run, probably too much. All right, with that said, that's the last example. So I will see y'all soon.